Thank you, James. And I must say that on the south of the wall, where I come from, you are Jaime Gobernador, okay? But anyway, thanks for the intro. My name is Alvaro, and the talk is Metaphors We Compute By. Why or how did I come out with this title? In 1980, 1 year before I was born, a book came out. It is called Metaphors We Live By. This book literally changed the philosophy and linguistic worlds because it understood that metaphors weren't just a matter of poetry and rhetorical flourish. They say, no, metaphors actually dictate how we live in the world. They are part of our conceptual system. But it's really hard to study the conceptual system of a person because everything is subconscious, let's say. How can we do that? They asked. Okay, let's study language. So language is a proxy they use to understand the conceptual system, which is directly related to metaphors. So they say, metaphors, they dictate how we think, how we behave, how we perceive, and how, at the end, the conceptual system is built. So you can say, OK, stop flying around because, I mean, there is a lot of beer outside, a lot of coffee outside, so why I'm flying with you here, right? So in the book, the first example they give is very, very powerful. They say, we understand argument as war. Because we understand argument as war, this is how we tend to argue with other people. What does it mean? We say, for example, that your claims are indefensible. Everything that is in italics is a metaphor. We can say he attacked every weak point in my argument. I demolished his argument. I never won an argument with him. His criticisms were right on target. And since we see argument as war, we come up with all these mental models of how arguments work, and that's how we behave with others. And they ask, what will happen if argument was dance? If we will have to cooperate with each other to achieve a common goal? That's the question they pose, and the question they try to answer along the book. So you can tell me, I'm not convinced. OK, famous last words. Let's talk about politics, right? We see what happened here. I'm not from the European Union, but I come from the Schengen world of Switzerland. I'm from the south of the world. I'm from Uruguay, but now I live in the cheese country. And yeah, if we talk about politics, we see what happened in the States, what happened here last year. We are always talking about winners and losers. Even in the States, they call them, the others, the sore losers. You lost against us. You don't matter anymore. Shut up. Why? Why do we have to live like that? Because we think argument is war. And with my vote, I won the argument against you, so shut up, and I do whatever I want. No, it shouldn't be like that. But we like to behave this way. It would be great if somebody could get me water. Thanks. I'm sorry for not preparing. You can still say that you're not convinced. OK, let's come to our industry, IT, and we call things human resource management. This is a completely broken metaphor. We humans are not resources. Don't try to manage us like you will buy machines for your company. We are not resources, OK? And now, thanks. Trigger warning. Today, actually, is the anniversary of the liberation of the, yeah, thank you, of the concentration camps in Poland. But there's people that they still think they need to give a platform to Nazis. Sorry for that. But it happened last year in a conference in the functional programming world. They had a person that believes that some others are inferior to them. The community complained. They say, we don't want that person on the conference lineup. They defended the choosing of that person for their conference. And to defend their argument, the organizers of the conference, they wrote a blog post called Wrestling with Inclusion at Whatever Conference. If you already are wrestling with inclusion, what else can I say? What are you wrestling with inclusion? Try to work together with inclusion. So metaphors, they change how we behave, how we think, how we react in different situations. But I'm a tech guy, so let's talk about computers. Back in the days, I don't know if you have seen this film, Hidden Figures. I haven't seen it because it's still not screened in Switzerland. And funny enough, the first screening, which was actually a special event this week, was on a ladies' night. So why we are trying to push forward this and only women can attend? It's pretty cool that they did that event, but anyway, next month, February, it should be open for everybody. But anyway, computers actually were these people. Engineers in their ivory towers, they will say, okay, we need to improve how the air flows through this wing, blah, 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 and then here's the equation, compute it for me. And these persons were the actual computers doing that for them. From there, then we got the electronic or automatic computers, and we came to understand what these machines that now we have were. We understood them thanks to this particular metaphor. So the origin of the computer industry is already a metaphor. And we need to see that metaphors, they enable understanding. That's why we use them all the time, literally all the time, even when we say literally. And if we go to Shakespeare, like a very common textbook metaphor will be Juliet is like the sun. Giulietta como il sole. No, I don't know how Romeo was speaking back then, but probably not in English. We understand that the life of Romeo orbits around Juliet. He cannot live without her. That is the light of his life, blah, blah, blah. That is what this metaphor is giving. But the metaphor doesn't need to be a one-to-one mapping between the idea of Juliet is the sun and the actual sun, because Romeo never said that Juliet gave me skin cancer, basically. I mean, so I'm sorry, but we don't need that mapping. We just need the metaphor to understand that particular aspect of what Juliet is or what computers are. Because computers don't stop at noon to go for lunch like the previous computers used to do. Or they are maybe solving the equation and thinking, I need to take care of my kids back home. That's one of the characters, or the actual person from Hidden Figures. He had to leave all her family at home to be able to be hired at Langley, for example. So computers, I'm pretty sure they're not thinking about their kids while they work. But a problem with metaphors is that they obscure understanding as well. This happened in the 19th century with the telegraph. The telegraph, as you probably know, French word, tele, distance, graph, writing. So it was writing at a distance. There was like the original telegraph with these things that were moving and you had to see it from a distance. And even back then, when they tried to improve the telegraph, because they thought about it as writing at a long distance or long distance writing, they had machines with one cable for every letter of the alphabet, and these were trying to probably punch that and literally write at a distance. It wasn't until we had Braille code, or Braille, I don't know how you say that in English, until we had that code for blind people to read, let's say, that we understood that our language could be codified into a different code. Then, in the previous century, Second World War, Claude Shannon came up with the theory of the information. He understood that we have a sender of the information, we have a receiver. We need to first translate the message into a format that is suitable for the channel. We have a channel, we have noise. The receiver translate that message back to its own language and then understand the actual message. That's how we communicate, and that's what Shannon explained on his thesis. So again, metaphors, they can go both ways. Let's say we have to be very careful on what we choose, or if we are not too constrained by the metaphor. There's a very nice quote from the book The Shallows by Nicholas Carr. He says, sometimes our tools do what we tell them to. Other times, we adapt ourselves to our tools' requirements. And metaphors are the tools of thought, so we have to be careful there. Now, metaphors we compute by, or metaphors and code. There's a great paper that somebody had the job, I don't know who here is a computer geek, but somebody had the job to go through the paper collection of Donald Knuth. So imagine that. I will be super grateful to review his papers, his letters, the mailing he did with Dijkstra and stuff like that. Somebody went through that, scanned all those documents. They are on the computer archive. One of these papers from the late 50s, I think, is what a programmer does. And the discussion of this best unknown paper is that as programmers, we are writing code to tell another programmer what was the solution we found for a problem. That should be your goal. That should be the programmer's role. Yeah, we are, of course, trying to ship something and get it out and get paid for whatever we are doing. But at the end of the day, this programmer could be us in the future even. And they say, I think the writing is a bit backward, but basically, we can write very complex code that if it compiles, it will be understood by a computer, but probably not by a human. So, of course, we can have that program working and whatnot, congratulations, but why not focus on getting humans to understand that? Because machines, they will understand it anyway. So we should focus on making our programs easier to understand, and how we get that and how this is related to metaphors. Types are the characters that tell the story of our programs, and the Haskell people can stop clapping because it's not those types. It's programming with abstract data types. This is a paper by Barbara Liskov and some guy that obscured here. I'm censoring that person. But anyway, Barbara Liskov, she wrote this paper, Programming with Abstract Data Types. She was trying to tell people back in the 70s that we should structure better our code, and she had to fight to get this through, because people say, no, that doesn't work. And what she's talking here is like data types like queues, stacks, lists, all those things. And the problem is that without those types, we just have operations on stream of bytes. It's literally zeros and ones, like, as we probably know. But when we try to choose the right data structure, we usually focus a lot of our time on the performance characteristics of the data structure, which operations are better, which ones are worse, slower, whatnot. And that's right, because we want the program to be fast, to use the right CPU requirements and whatnot. But data structures, they also tell the story. If we want to have people, let's say, in a collection, of course we can just use a plain array. That's fine. But maybe people cannot be duplicated, like the attendees to this conference, or voter fraud in the States. If we have that requirement, actually what we want is a set. So when we choose a set for our program, we are telling that future programming, but maybe us, this is my metaphor for that plain array. Or it could be a linked list with this ordered access to elements. It could be a queue, because I want people to queue for the coffee, first come, first served, for example. Or it can be a stack. We know what all this is. But the point is, everything can just be an array where I implement some different operations on top of them. But when I say set, queue, stack, whatever, I'm actually telling you this is what I mean with this piece of code. The array will work, will be fast, whatever, but you are not telling me what you mean by that data structure. So I think that a program explanatory power is the measure of its own elegance. If the program is not explaining me what it's doing, I don't think it's elegant. Data structures, they have explanatory power, and that's why we should use them a lot. Then in computer science, something that happens a lot is when we manage to do a cognitive leap, so we understand something much, much more better. For example, we can have task scheduling. We need to process things in order. Actually, what you need or what you're trying to do is to have a queue. And when you have a queue, you have queuing theory. So you have the whole theory behind queuing, the whole mathematical power that that brings, because you understood that a scheduling task in certain order was actually queuing theory. Or we need to do route planning. The metaphor for that in computer science is actually graph theory. When we understand graph theory, we have all the power that we've seen in Google, for example. Something very interesting happened with database replication. Back in the 80s, there was a paper about replicating data, and they found the solution was like spreading rumors, gossip. It's a very nice metaphor. It's easy to understand. I tell this node will choose two other nodes, spread the rumor, and so on, and like that we replicate data. But when they were writing the paper, they actually found that it was better explained by the epidemics metaphor. How epidemics spread on a population. And when you have epidemics, you have the mathematical theory of epidemics for free. And actually, they use this theory to explain the algorithms. Because you managed to find the right metaphor for that, you did the cognitive leap, you went ahead much, much more than what you could do just with gossip. So everything is a metaphor. I know you don't believe me, maybe. Let's go to distributed systems, metaphors. Whatever is italics, metaphor. There are more. I didn't want to mention all of them. Whenever nodes need to agree, nodes, they don't agree. People agree. On a common value, we start a consensus voting metaphor, algorithm to decide, nodes don't decide on a value. There's usually a leader. There are no leaders, but we have them. We understand what a leader is doing. Process that take care of making the final decision based on the vote it has received from its peers. Node communicates sending messages over a channel which might get congested due to much traffic. This could create an information bottleneck with queues at each end of the channels backing up. And finally, these bottlenecks might render one or more nodes unresponsive, causing network partitions. Is the process that taking too long to respond dead? The process, they don't die. And so on. Metaphors everywhere. Intermezzo and final part of my talks, if you were worried. Packaging. I had to put this somewhere. So I mean, it's a very nice metaphor, but please, let's not be that packaging. That you need a scissor to open your scissor that you just bought. Like, we don't want to be that in tech, let's say. And you say, OK, but this never happened to me. No? If you wanted to build Haskell back in the days, you need GHC is required to build GHC. OK? When I tried that, it was the only time I saw the matrix, just like characters flying through my screen. It ended up in an exception. So no, it doesn't work. A much better metaphor, and I have to put this here as well, are containers. Because if we want to understand packaging, I think we have to be like containers. Not like every aspect of containers, like a speaker explained yesterday, because it won't be a one-to-one mapping. But containers are standard. They ship anywhere. They can fit on train, ships, trucks, stackable. They are reusable. We have all that, or many of these characteristics that we understand from containers. We have them in Docker and so on. My memory just went away, but let me keep going to the talk then. A problem that we have with containers, as the speaker said yesterday, for example, we are not waiting for a ship to be completely stuck with containers so it can be shipped. We have a much more time to response, right? Also, did you know that containerization was restarted in England back in the Industrial Revolution to send stuff on trains? Switzerland has the biggest container ships in the world, and those container ships are the one that pollute more our environment. So do we want to be like that? I guess not. And this is a question maybe for Alexis, I don't know. Who is going to be the next Halley? Halley, the British guy that not discovered the comet, but you know who is Halley, I guess? He actually, it seems he started a company with his diving bell to recover stuff from shipwrecks. So I wonder who will be the company that will be recovering the shipwreck of the containerization era. I don't know. Maybe there is a startup idea there. I don't know. And I think this first really good with microservices. And there are a lot of very great metaphors here. Because microservices related to containers, how we ship them, we get decentralized governance if we go through this blog post and the metaphors they use. They bring us the idea of the monolith versus the microservice. Small is better than big that is cumbersome. We have this isolation. We have this David versus Goliath. Basically, we are bringing the power back to developers. We are saying, if you containerize all these things, you are in power of what is being shipped. And as I said, when you bring power back to developers, you become a king. And if you read that blog post about microservices, at the very end, last footnote number 12 or 13, I think, they mention you could argue that all of this was just Erlang. And that was my feeling when I was reading the blog post. But isn't this just Erlang? But the problem is that Erlang, I think, fails completely on the choosing of metaphors. Imagine being a marketing person going to sell your product and you say, yeah, we have the actor model. Like, really? That's the quote. I'm not going to go there. My question is, what is Erlang's elevator pitch? You know? I was an Erlanger for 6 years at least, so I know that suffering. Because if we want to succeed, we want to master the art of metaphor selection. We want to get people to understand things first. Maybe with the wrong metaphor or not the metaphor that covers every single detail. Maybe containers have bad things, but at least a marketing person can sell that. They can explain that. You can explain that to your manager, why you want it, what's there. Then when they understand it, we really tell them how things work. For me, when I was selling RABBITMQ, let's say, people ask me, is RABBITMQ a shop server? No, it's not. It's this and that and blah, and boom, bang. Come on, dude, shut up. This is enough to understand what RABBITMQ is. You bought it? OK, let's see what RABBITMQ actually is. Because the right metaphor has the power of amplifying meaning. We need to master that. And finally, I think our program is the metaphor for the solution that we found to that particular problem. References, credits, and thank you very much.